Thanks for joining us. This is our second session. If you missed the first one, you can, of course, go back and see it. The link is down below. Today, we're getting under the covers a little bit more. We're going to go into the technologies, a bit more specifically about how you would look at moving from a virtual machine-centric workload into a containerized, albeit with virtual machines workload, where perhaps those come into Kubernetes itself and move you away from this virtual machine on VMware estate. So as before, I'm joined by David O'Dwyer.
Oh, thank you very much. Hi, I'm the founder and director of LiveWyer. We are a cloud infrastructure modernization consultancy. We deliver that through Kubernetes expertise, solutions architecture, infrastructure testing, and capability development, all with a product-centric mindset.
We're also joined by Dan. Dan's from Pure Storage.
Thanks, Dan. Yeah, Dan Punch. I'm a senior systems engineer at Pure Storage. At Pure Storage, we have a data platform that provides highly resilient, high performance storage for all workloads. And so I'll be talking quite specifically about what Portworx brings to this conversation. VMware is an enterprise solution. It's proven for decades. Why would I move to an open source solution like KubeVirt?
Well, the first thing is to realize that you're not just moving to KubeVirt, but you're moving to a technology called KVM, which sits underneath it. As people in the industry should know, KVM underpins all of the major cloud providers' virtualization technology. Yeah. It is something which is baked into the Linux kernel. It is something which has been developed over a decade. It's something which has seen huge amounts of community support, not only from in the kernel space and virtualization space and hardware space, but also in the user space when it comes to the tooling and ecosystem of how to utilize it. KubeVirt is developed off of the back of KVM. They're providing essentially a user space layer on top of that interacts with Kubernetes. You get the rock solid maturity of KVM from a low level OS perspective and kernel perspective, but then you get access to all of the modernization aspects of Kubernetes and all of the dynamic computing aspects of Kubernetes that it brings.
When people think of Linux, they think of operating in the command line. Mm-hmm. And you've got WinOps people who are coming from an environment that's been very developed over the years to allow them to operate in, that Xerox environment. Mm-hmm. Very wizard-based. Do we have to throw that all out the window doing this in Kubernetes?
No. And one of the benefits is that you get mature interfaces on two levels. You get a very low level mature interface, but you also get this very high level of maturity as well. Underneath the hood, you still have KVM running. It's still Linux, it's still an OS. You still have the ability to SSH into the servers. You still have ability to go into the base hypervisor systems and see what's actually happening within that. You still have to monitor that. The same metrics still apply. Nothing's changed at that level. It's just the levels of abstraction have changed. Underneath, it's the same processes with access to the same compute and the same network and same storage. So on that level, it should be very familiar for people coming from a traditional, say, Linux operating system sysadmin background to be able to interrogate and investigate it. Now, what you now have is the added bonus of having an API. And now all of this has an API on top of it. So those coming from a more traditional WinOps background now have the ability to interrogate this through user interfaces, traditionally sort of web interfaces, web tooling, and be able to consume and access and get all of the information that they were getting through traditional WinOps, ClickOps style interfaces, but getting them through more modern UIs.
And if you move to an enterprise solution, KCS has a GUI that you can use that makes people at home. Of course, the aim there is to make it so that those users coming over from VMware are at home.
So it's interesting though, we're talking about the ease of use with nice interfaces, GUIs, and it is important that those things are still there because at the end of the day, we are still working with humans doing this work to facilitate that transition and to account for the skills gap. And we need to address that. But also at the same time, what I've noticed in conversations with large enterprises is that regardless of how easy these tools like VMware may be, there's a growing sort of tide or an ambition to move away from fingers on keyboards. At Pure Storage, we're well known for trying to make things as easy as possible to use. Portworx itself has got GUI interfaces. However, there are more and more organizations that really they're not interested in that. What they're interested in is a storage layer that's programmable, that's API driven. It doesn't need people to interface with it. The easier it can be automated, better it is. And so if you've got this ambition to move more towards infrastructure as code, then actually those kind of things that felt important over the past 10 years, with attractive vCenter GUI, actually they become less important. What's more important is actually it's easy to automate. It integrates with things like Ansible, and that becomes more of a priority.
You really want a concise way of inputting for efficiency, and then you want an enriched way of showing the information, because we can take in a large amount of information through a dashboard, but we don't need a dashboard to input that information. And I think we used to conflate these pieces, right? Everything had to be rich on the in and the out.
I would say 10 years ago, when I first saw the first live demo of Kubernetes, and this was off Old Street by a gentleman called Craig Box. Hi. He did a demo of this, and it was the point at which I went, they get it. But it wasn't the point they get it from an automation or from an API they got the sysadmin principles. They got the operational principles. You could tell that was what was at the core of this offering, is that it had the automation, it had the API, it had the abstract, but at the core, it lent heavily into operation, like a real strong operational foundation. And that's what drew me in, and that's what drew my company into working in this field. And I think that's carried on through.
So we think about vSAN. vSAN was a virtual SAN storage area network, and this allowed you to separate the storage from the consumption to create an abstraction layer between those two, so that you no longer had to tightly couple, an anti-pattern in software engineering, an anti-pattern generally, between a piece of hardware and the thing that was consuming it. Does Portworx solve this same challenge, and what sort of benefits does this bring?
We need storage software-defined storage to take the role of vSAN, and that's what Portworx is bringing. So Portworx is addressing those enterprise data management features that vSAN brings. Capabilities such as replication, asynchronous replication between availability zones and sites, but also snapshots, the ability to roll back to previous points in time, security features such as encryption on disk. These are all essential in a VM environment.
And David, just so we understand from a practitioner's point of view, you don't have to define software-defined storage for this. You don't have to employ Portworx in this process. But what would it look like if you were to just go with the default, which is cloud-native storage, right?
Yeah. So if you're going for the sort of typical cloud-native storage offering from, say, a public cloud offering, say AWS, for instance, then typically you'd be provisioning at the point of scheduling a container. If you're asking for some persistent hardware, the cloud provider controller would then go off and talk to the AWS API and say, essentially, give me a persistent disk. It would then attach that persistent disk to the underlying node or instance that you're running on, and then it would mount that storage to the container. And so when the container started, it would have access to that storage. Now, within the confines of that availability zone or that data center, it does have the ability of essentially like a USB drive. It will unplug and plug it back in, unplug and plug it back in. But the moment you move outside of the confines of that data center, that storage doesn't travel with you.
So SRM, for those who aren't familiar, is Site Recovery Manager. And what it did for VMware was to allow you to go from a single tower to fail over to another tower in another data center. Those data centers were traditionally within 10 milliseconds of each other, because that's a constraint in technology. If you go beyond that, these systems have to wait for them both to agree in a synchronous environment. So that was their innovation. And as we move into Kubernetes, we move away from a 2 data center paradigm to a 3+, which accommodates quorum, which we'll come back to. We've got an engineer called Moth. He's an excellent engineer. He explained that a lot of people are talking about SRM and Very few are doing it. Now, if you remember being a teenager, there was a similar paradigm there where people weren't necessarily doing the things they were talking about. But I'm going to hand over now to David to explain under duress what he thinks I mean.
Well, that is the best intro handover I've ever had. Thank you. So essentially, when we're talking about SRM, we're talking about it within the Kubernetes space. I think one thing that's important to note is once you've moved the VM into the Kubernetes space, it treats it as if it's any other type of deployment. So the way in which a KubeVirt wraps around the concept of the KVM is very similar to how it wraps around the concept of a container with containerd. And so it's a first-class citizen in that Kubernetes ecosystem, which means you get all of the benefits of having a flexible dynamic scheduler that can work across multiple different data centers. At this point, Kubernetes does have like topology aware. It has awareness of data centers, but at its core, everything is based around labels. You have this completely flexible, flat label-based system, which allows you to write very complex rules and which enables the scheduler and the orchestration within Kubernetes to make really good informed decisions at the point of a failure. So within Kubernetes, you'll be able to say, I expect there to be X of these up at any one time. And you can also say, I'm okay for this to be scheduled within these constructs. I'm also primarily would like it over here, but if this is unavailable, I don't mind it being over there. But also, don't put two of them on the same hardware, separate them out, spread them out, and do it this way. Oh, and by the way, if you're doing any work in terms of taking a system down, or if there's a rolling update or some other event when it's over there, always make sure that there is at least 1 or 2 or 3 of these running. So you can put some very advanced rules into the scheduler so that at the point of time there is a failure, it knows exactly what to do and the best way of doing it. Typically, when you're working with VMware and vSphere, you are, as an operator, you are deciding, you are placing this within this area. You're saying, I'm making this decision, I'm placing it on this hardware, I'm putting it in this host, I'm selecting this set of hardware. Whereas typically with Kubernetes, you are scheduling, you are giving it across the cube, you're giving it a bunch of instructions, and you're saying, based upon these parameters I am giving you, put it in the best possible place. So it's a very different engagement when you're working with your workloads and your compute than there was within vSphere. It's baked in that idea that Kubernetes will be making a decision on the location of your compute. So whereas, alluding to what you were saying before, people may say they are doing and configuring and enabling this technology, but it's not required. Whereas within Kube, it's baked in.
We've covered the ability to move your compute around. We've covered the ability to abstract your storage. It makes everything able to move between those 3 hosts. 3, of course, means that should you lose 1, you have 2. Means that in a worst case scenario where you lose 1, you're only losing 33%. It also means that there's only ever going to be 33% waste if you're planning on that outage. Mm-hmm. Change that to a VMware active passive setup, you've got a 50% waste if you're going to plan to do that. So already that's a bit of a saving. As we look at the network piece and how the networking works in these scenarios, if we look at KCS, which is Kubermatic's version of this virtualization, we have a paradigm that's very familiar to me as a cloud architect, is this idea of a virtual private cloud. Now, Kubernetes is built on services, so we don't have an IPv4 setup in there. I mean, it's layered on some of this, but the container network interface for Kubermatic's KubeVirt, they provide an interface to use the native abilities of a VM. So that IPv4 setup is then able to be extended out into the namespace, and your services that are within your cloud native namespace can interact with those virtual machines, which all sounds very similar to how we would have shelled out to another system that's outside of Kubernetes. So this sort of paradigm is happening anyway in your estate if you're interacting with virtual machines. But here it's all able to be defined and deployed as a manifest, and your application can move as a whole into these systems, which means you can do ephemeral environments for testing and just develop that velocity from these systems, which was previously quite difficult to do.
And when we're talking about moving into Kubernetes, we're also talking about moving into other areas that the ecosystem enables. So specifically on the networking front, you're now moving into a space where there's a number of very mature service meshes. And these service meshes give you a layer, where we talk about layers of logic, like layer of logic within the compute, layer of logic within the storage. When we're really talking about the layer of logic when it comes to the networking, there is the base that KCS is providing, but then there is this additional overlay that you get from Kubernetes when you start moving into service meshes like Linkerd or Istio. And suddenly you can start overlaying those capabilities into the VM space as well. So there's been a number of client engagements where we're having to construct encryption gateways because we're trying to carry the pod-to-pod or container-container encryption across two VMs to other network real estate and other hardware real estate where the software-defined network doesn't reach by default. And that adds a lot of complications, especially when you're moving into key rotation, monitoring, logging, etc. Whereas by obviously bringing the VM into that network, into that service mesh, it's a first-class citizen. It gets all of these capabilities. All of the capabilities around not just security, so pod-to-pod or pod-to-VM encryption, you suddenly start getting traces. You start getting all of the low-level metrics. All of that is baked into a single sort of data source for you to interrogate. No longer are you having to cut across multiple systems when you're tracing to try and get insight. It all comes under one data source.
So we've covered the networking, we've covered the moving of compute, we've covered the moving of storage, right? Those abstraction layers.
Yeah.
Virtual machines, they're very much the pets. They get looked after carefully. You know, it's very important that we are able to restore them to a point in time. We've really got two aspects to this. One is the availability, and I feel like we've gone through that. Now we need a remedy to an outage, right? A remedy to a deletion, a remedy to inavailability.
Yeah.
That's usually backup. How does backup change when we move to a KubeVirt KCS solution versus how it's done today in VMware?
So all the major data protection providers out there, they've had a couple of decades to really fine-tune the way that they integrate with VMware. And initially, somebody did a P2V migration onto VMware or whatever virtualization platform, and all those ISVs had to play catch-up a little bit, because of course the data could be protected, but what you wanted to do was take advantage of the fact that you virtualized and it's now exploitable as an image, effectively, a snapshot image. And so the way that we've all come to expect virtual environments to be protected is that, for a start, that we can back it up in such a way that when we recover it, we've got the ability to not just extract individual components out of that image, but also recover it as a snapshot so that we get something that's can be booted up straight away, and we can take advantage of the fact that it's been virtualized. Of course, the data within that image and within that virtual machine, we also need to be able to protect it in such a way that it's usable when the VM is recovered. As a vSphere admin, for example, I have quite high expectations as to how data is protected in a world where we've containerized our VMs. Portworx already has a mature product that protects containers, protects containerized applications. So PX backup gives us the ability to protect containers at that granular level. And of course, VMs now become, they benefit from that mature process already. We have to make some considerations, however, because this is still a new technology. So we're able to back up those VMs incrementally. So if you're using Portworx Enterprise, you get the ability to do effectively CVT type backups, plot level incremental backups.
And on that point, with Portworx platform within Kubernetes, I understand that Portworx supports the new standard of volume snapshots. So I know that previously you would have a number of vendors or a number of providers would provide their own custom resources. And so you would have some vendor-specific resources and some vendor-specific aspects of your workload. But as what Kubernetes has been doing a lot over the last few years, has been looking at these areas where there's been this sort of divergence of standards and generating standards. And so within the construct of Kubernetes, you have this idea of a volume snapshot. And then if you're running that within a local development environment, then that can do one thing. Whereas if you're running in a productionized environment, that can do something else.
So your existing, let's say you've got a contract out with one of the backup providers. Are those still going to work in your new virtual machine estate? It seems like you'd just be, you've got an agent, it goes through the network, comes out of Kubernetes, stores that block level replication, something like that, or transaction logs if you're doing databases. All that should still work, right?
Well, those applications that are running within the VMs that are being protected by agents from backup software vendors while they're living on VMware, those same agents will just continue running exactly the same way once the VM's been migrated.
This year specifically, back in February, DORA came into effect.
Yeah.
And one of the big parts of DORA was formalization of the time you need to recover your site from. For a site that is built in VMware, the challenge of moving to a 2-hour window for recovery for that whole workload estate is a big challenge. The challenge of doing that with something like Portworx on a fully containerized estate is not trivial. You still need to test these things, but is built into this software, as I understand it, which is drawing a lot of interest in the industry from those who are regulated. And to be under DORA, it's anyone who serves one of these clients. So if they're part of national infrastructure, if they're part of banking, anything that could affect a country in the European Union's economy comes under DORA. And if you're a supplier, you become a supplier to one of those, you're also under it. So just so you know, this might become your problem. It might be your problem now, and I'll link to a webinar I did on some of this as well. But how does disaster recovery work when we have a solution that's built inside Kubernetes that uses VMs? What would it take to hit that 2-hour window for your estate?
From a compute perspective, as I discussed earlier, the VM is treated as a first-class resource, the same as a pod or a deployment. And therefore, to get your resource into Kubernetes, for it to be scheduled, it always requires you to do a lot of the groundwork of putting in and specifying what it is, how it works, what the definition of running is, what the source of it is, and what you want to happen to it if it was to fail. It requires you to define that up front. And even in certain situations when you don't define it, Kubernetes brings a lot of sane defaults based on a lot of operational experience. In addition to that, Kubernetes over the last few years has really shifted from looking at the big sort of headline features and has really focused on maturing the sort of low-level operational features that have been there for a number of years. It's really started to look at maturing the edge cases a bit more, looking at some of the new common patterns that users are now developing. If you think back to when Kubernetes was originally released with the team from Google, a lot of the construct was based on Google's understanding of how to operate things at scale. Well, over the last decade, you've had the community has rounded with Kubernetes and started to import all of their definitions of how they need to operate, what they require. And Kubernetes project has done an amazing job at being able to collect those use cases and really prioritize the ones that give the maximum benefit. And what we're seeing over the last 2 to 3 years is a lot of what was originally being seen as edge cases, but now are much more modern use cases. And a lot of that is driving maturity in areas that really get to this level of disaster recovery, operational resilience baked in with the default.
So you bring up an important point there when we're talking about addressing the requirements of DORA. That 2-hour recovery time objective, to achieve that with backup alone, when applications are, the databases, the amount of data will determine how quickly you hit that with a backup solution. So you brought up the topic there of snapshots, and I think really it's snapshot that are going to allow you to achieve it. And so with Portworx, we can snapshot volumes, mutable snapshots as well. Very important. Of course, what we're addressing here is not just a disaster, but also cyber threats as well. But of course, if you've got a large estate where you have certain applications, certain VMs that need different SLAs, different recovery points, so which of course is a different frequency of snapshot. You need to be able to define those storage classes. And of course, with Portworx, we can define different storage classes, which can be differentiated by different underlying storage, but also different data protection rules and SLAs. If you've got lots of different storage platforms with their own ways of interacting with Kubernetes and their own ways of achieving things like snapshotting, then that becomes very possible to manage. And of course, if you need to adhere to DORA and other regulations, you need to be able to do this easily at scale. So having a storage abstraction layer like Portworx Enterprise allows you to very easily create those storage classes that allow you to align applications and protection of VMs with those SLAs.
And I imagine because you're putting in quite a healthy amount of business logic into that area when it comes to the backup and the restore, I suppose one of the benefits of leveraging Kubernetes in this space is the fact that it is an abstract. So that if part of your product that you're delivering to a customer includes a lot of the strategies around how to handle data, by baking that into the Kubernetes abstract, that customer is not tied to Portworx. It's not tied to that as a solution. It's something that could be delivered in many different areas. So one question on that, I suppose when I think of backups and restore, traditionally those have been operator-led activities. Now moving into Kubernetes, where these are more accessible, it's an accessible API, these are accessible resources, the ability to initiate a backup and initiate restore is now much more on the developer or user side. How have you found that's changed? How has that changed how Portworx has approached?
The way that Portworx enables developers to self-serve with backup is a really powerful thing. And you can again use labels. Kubernetes is built on labels. Labels are essentially metadata, right? Yeah. Which means you can cut in any which way you need to. So you can give, as the operator of the Kubernetes cluster, you can make sure that everything comes up with a backup label, and that will receive a daily backup, okay? Because the last thing you want, and this is very much about coming from a VMware estate, the last thing you want to do is find out that it wasn't backed up at the point that they need a backup, yeah? And by backup, I mean recovery. So you can make it easy for them to do that. You can also make it through this portal in Portworx Backup, where people can go in and self-serve as users. You don't have to be an administrator for that, where you can go delete other people's backups. You can just be a user. And of course, all these things can be fired off over API, because Portworx built this to be API driven, which means that your GitOps pipeline, before it rolls out to production, could call a backup on production. And as part of your rollback procedure, should it be needed, you can call a restore. And there's other bits like, quiescing databases and things like that can be done as well. All this is great, right? It's going to work when you get there. How do you get there? How do you move virtual machines into Kubernetes, into KCS?
And I suppose it really does depend on your starting point. For some organizations, their starting point will be VMs, which have been organically developed over a long period of time. That these are machines that people have manually been going into, configuring and maintaining. For others, there will be some basic scripts, but those scripts may be, we run these 2 years ago, we haven't run them since then because the machine's been on and working fine. For others, they're much more higher up the maturity scale, where they've got some more robust configuration management. And so if we're starting at the lower end, the more organic side, then typically the strategies you're looking around then is a lift and shift of the base VM image, if that's what you're looking to do. Now, if we go back to what we were talking about on the first session was, before you do the lift and shift, interrogate what's on the system. Because ultimately what's on the system may be a single process or two processes. And so the act of you extracting the process or the configuration and deploying that as a container, or creating a fresh, more configuration management driven version, isn't that difficult. And it may be something that you want to do at that stage. But in those specific environments where you've discounted those as options, then you are looking at moving the base image, the base VMDK into an image within KubeVat. Now, to do that, there is some relatively new exciting tooling in the community at the moment. One of them is called Forklift that can help manage that at scale. There's other utilities such as Packer and other command line utilities that allow you, again, at scale, to be able to script and automate these processes. So moving up the stack slightly, if you're moving into the configuration management space, then the good news is that it's really straightforward, because all you're doing is you're taking the configuration management scripts that you have, be it Ansible, Salt, Chef potentially, and you're applying them to a new target. And again, using utilities such as Packer or other tooling, you're able to quite easily point it at KubeVirt destination rather than a VMware destination. And you'll find that for the vast majority of what you're building, you will get a like for like.
So the benefits of moving to Kubernetes, because changing people's opinions, changing people's working practices is hard, but you still get a lot of people who want to learn new things, right? I know we ourselves all want to learn new things. And that ability to see manifests being run, to learn a few new commands and see what used to take weeks to months to be done in hours with relatively easy code, and we're in a day of AI. So having a system fix your dodgy YAML is very easy now. We don't have to worry so much about slipping up over the syntax to run this. And you also get very intelligent terminals now as well, which can see what's going on in Kubernetes and help you troubleshoot directly from the terminal. This is a really exciting time for them to grasp something new and feel empowered, and then show to their teammates that it can be done, and maybe even do some leadership in there as well.
Carrying over from your point now, I think it is moving into the Kubernetes space via VMs. For a lot of engineers who have traditionally been working heavily with VMware and vSphere, it's a very safe landing zone. The ability to move into that ecosystem, but also move into it from a position of understanding the VM, understanding the KVM, understanding the Linux OS, I think is a really a safe landing zone. Beyond that, I think one of the main draws of moving into the Kubernetes space, and again, something which drew me into Kubernetes when I saw it back in the day, and more so to this day, is that it forces you to think about things around your workload up front, and it's baked into the proposition. So for a number of engineering teams over a number of years, when it comes to sufficiently designing things such as failover, designing the idea of scaling, architecting certain patterns, these things have been secondary to delivery dates. They've been secondary to getting things done. Whereas with Kubernetes, for a lot of these teams, it is a redo. It's the ability to draw on all those years of experience and technical debt and start fresh, blank slate. And Kubernetes wants you to do it the right way. It desperately wants you to build the abstracts. It wants you to build the workflows. It wants you to work with the grain. And then over the last years, a lot of tooling and a lot of other processes have come on board.
So just like you were saying, how Kubernetes provides an opportunity for VMware admins to develop their skill set, but also looking at this from a storage point of view. Of course, storage is always, the storage admin has always had a very tight relationship with the VMware admin. It's also a great opportunity for those of us who are very well versed in enterprise storage to then understand how that integrates with modernized, containerized workloads, our understanding of the requirements around data protection, high availability, all those features that we're getting from Portworx and Portworx Backup. They're all very relevant. And I think this is equally an opportunity to bring all those teams together.
So I think one of the other draws that you've got is the fact that you're moving from a quite clearly heavily garden-walled vendored environment into a very open and open source driven environment. One of the things that scares people when we talk about open source is the fact that there is infinite combinations of these technologies. For a lot of people moving into that space, the options are sometimes a downside. But if you're looking at the ecosystem as it stands today, you have a number of companies like Kubermatic who have come in who've basically been able to build a very safe starting point. But it is a starting point. It's not an end point. It's the starting point for someone on their open source journey. And having that underlined with something like Kubernetes, which is acting as this sort of universal abstract, this system which vendors plug into, technology plugs into, this sort of board that you can develop from, I think is a very, very powerful, potent tool. And it's even made even more potent because it's also the platform which your customers are running. It's the platform where your customers are now developing their solutions in and moving their infrastructure in. So in some ways, I look at it two ways, basically. I look at one way, it's the platform for enabling and accelerating your own company's development, but it's also the destination for where your customers are expecting your software to go as well.
Yeah, your deliverables should be compatible with Kubernetes, and then everything becomes portable. So this has been the second of 3 parts. We are going to move into a live event in London. We will be making a recording of that as well. In that session, we'll talk deeper about how to get going, what those first projects might look like, and unpacking any questions you have. Today, we've really gone through what the Rosetta Stone is between these technologies and what the draw is to this new way of working. And I hope that you can see that there's a bright future for the engineers who are interested in this, and that the step up to moving to this world is not so great. Thank you for your time, and we'll see you soon.